Hi there, this is Miss Wesley, and we're going to do Unit 10 Skill 3 today, which is all about sector area. So our essential question for today is, how do you find the area of a sector, or just part of a circle? So we talked about the word sector before. Again, sector means a portion of a circle. It's going to be a central angle still. It's got to come from the center. So we know how to find areas of circles. You've done that for a long time, but now we're going to figure out, well, how do you only find the area of part of a circle, or that specific sector? So again, make sure you copy that essential question down. How do you find the area of a sector or part of a circle? So there's three very specific steps for finding the area of a sector, and it's essentially going to be the same thing over and over and over again. The formula that you do have to memorize, though, is right here to the right. So it's angle over 360 equals sector area over the area of a full circle. So I typically refer to these as sector area, so SA over TA for total area. So step one is to plug in the central angle for the angle symbol. So for instance, whatever this angle is here is going to go in for the angle measure. Then you have to find the angle of the entire circle to start. So in order to do that, you have to make sure you know your radius, which hopefully they will give you. So our area of a circle formula is, I'm going to write it underneath just so it doesn't look blurry, pi r squared. Again, that's on your reference sheet. And then you simply cross multiply to find the sector area or find the central angle, depending on what you're looking for. So the idea behind this formula is that whatever ratio the angle is in to 360 is the same ratio that the area is in compared to the entire area. So if that didn't make too much sense, we're going to show you how it works in these first couple examples. Let's take a look at what we got here. Okay, so in example 1, it says determine the area of the sector in terms of pi. So make sure you note that. That means we're going to have a pi left in our answer. So we can see here that our angle is 120 degrees, and we know that the radius is 9. That's what this 9 is representing. So I always want to start by writing my formula down. So it's angle over 360 equals sector area over total area. And then this formula, just like if you think back to when we used the density formula, you can solve for any variable or any of these four pieces. You're never going to solve for 360 because 360 is always going to stay. But you can use this to find sector area, which is what we're going to start with. You can use it to find the angle. You could also even use it to find the total area if you needed to. So in this case, we want to find the area of the sector. So I'm going to let my SA be represented by my X. I'm going to plug in 120 for the angle. So 120 over 360 equals X, since I'm looking for my sector area, over the total area. Now off to the side here, I'm going to use my area formula. A equals pi r squared. And because the r was 9, if I was to plug into this, pi times 9 squared. Well, 9 squared gives me 81, so my total area would be 81 pi. And I'm going to leave that alone. I'm not going to type it in with the pi, again, because it said leave your answer in terms of pi. So this 81 pi is going to go in for the total area. So I'm going to move that over, 81 pi. And now I can go ahead and cross multiply. I know the 360 times x is just going to go ahead and give me 360x. On the other side, I'm going to do 120 times 81. And I get 9,720 pi, because remember you have to bring that along. My goal here is to solve for x, so I'm going to divide both sides by 360. And again, notice that I'm only putting the 9,720 over 360. I didn't put it with the pi, because again, I want to leave that pi alone. And when I divide, I'm going to end up getting x equals 27, and then I have to put the pi along. So my final answer here is 27 pi. So if you think back to how we did this, the 81 pi represented the area of this entire circle. We wanted to know the area of just this shaded region. So it should make sense that the area is smaller than that, and that it is because we got 27 pi for the area of this sector. All right. Let's take a look at example 2. It says in the diagram below, the area of the shaded sector is 14 pi. So notice that they're giving us the area of the sector. So I'm going to make sure I note that. The area of the sector is 14 pi. The length of AB is 6. determine and state the measure of ABC. So this time, notice where our X is, we're looking for the central angle. So again, I'm always going to start by using my same formula, and I like to jot it down. Angle over 360 equals SA for sector area over TA for total area. This time the X is going to go in for the angle because that's what I'm looking for. So I'm going to have X over 360 equals, now the sector area is what they told me up above. They said the sector area was 14 pi, so I'm going to put the 14 pi in for that. Now my total area, remember, you have to do that off to the side on your own separately. So we know the radius here was 6. So area equals pi r squared. So we're going to plug in 6. 6 squared gives me 36 pi. So now that 36 pi is again what's going to go in for the total area right down here. So we have 36 pi. Now notice that I purposely left the pi in that because since they gave me the sector area in terms of pi, and I have a pi over a pi, those get to cancel out, so which is a really good thing. Now if you don't have a pi over pi, you can't cancel them. You just have to keep bringing the pi along like I did in this first example here. So now that we did that, we're going to cross multiply. 36 times x is 36x. 360 times 14 is going to give us 5,040. Again, my goal is to solve for x, so divide by 36, divide by 36. X equals, oh, I did that wrong, sorry. And again, 5040 divided by 36, we get 140. So again, if I go back and check, does this answer actually make sense? My goal was to find this angle here that definitely looks like less than 180 because 180 would be half a circle. So 140 does make sense for this answer, right? So again, if you don't have this formula memorized at this point, maybe jot it down on an index card somewhere that you're not going to forget it. Angle over 360 equals sector area over total area. We're going to look at just another couple examples in the back, and then you're going to go ahead and try some practice problems. Okay, so example 3, and both of these again come straight from the Regents exams. That's why we like to give them to you so you're ready for the level of difficulty that you'll see. It says triangle FGH is inscribed in circle O. The length of the radius of OH is 7, and FH to OG are congruent. So I'm going to mark that. FH and OG are congruent. Determine the area of the sector formed by angle FOH, and again in terms of pi. So I'm first going to make sure I know what I'm looking for. I'm looking for the sector area from FOH, so this entire sector, everything in this space. So thinking about my formula, if I first jot that down off to the side, angle over 360, oh that was a 3, equals sector area over total area. Now, I'm looking for the sector area based on the question. Again, determine the area of the sector. So that means this has to be my x, which means I have to be able to fill in both of these other spots. So I'm first going to try and figure out, well, what is my central angle going to be? What's the measure of angle FOH? All I know right now is that the radius is 7, and they told me that FH is congruent to OG. Well, I'm noticing that OG is a radii because it's coming from the center to the edge. And so is OF. OF is also a radius. And if one radius has a length, it's going to be congruent to the other radius's length. So I'm going to go ahead and mark that. F to O is congruent. And now looking at it from this point, OH is also another radius because it's going from the center outward. So this triangle that I have here, OF is a radius, OH is a radius, and OG is a radius. And it told us that OG was congruent to FH up here. So that means all three sides of this triangle are congruent, which means I have an equilateral triangle. And if you think back, equilateral triangles, in your little side note, equilateral triangles have 3 congruent angles. We know the angles in a triangle add up to 180. So 180 divided by 3 gives us 60. So this angle right here, that little pink angle, is now 60. So that helps us out because I now know my angle. So I'm going to start to fill this in. So 60 over 360 equals x, because again, I'm looking for the sector area. over the total area. The 7 that they told us is a radii. So off to the side here, I'm going to go ahead and find the area of the entire circle, again using pi r squared. So pi times 7 squared. 7 squared gives us 49 pi. They wanted it in terms of pi, so I'm going to leave that alone. 49 pi. All right. At this point, we're ready to cross multiply. So if you're someone that's comfortable doing that, why don't you go ahead and pause the video and then try it for yourself. If you want me to walk you through it, I'll go ahead. So 360 times x is 360x. 60 times 49 gives us 2,940. And again, I have to make sure I keep bringing that pi along. I'm going to go ahead and divide by 360. Divide by 360. And when I do that, that's not the right answer. All right, you might have heard me say that's not the right answer, and it's because when I first looked at it, I hit a decimal. But if you convert it to a fraction, or if your calculator left in a fraction, then you're good. It is possible to get fractional answers. I just forgot that that was the case for this one. So when I divided by 360 as a fraction, I would get 49 over 6. And remember, we got to bring that pi along. If you weren't looking at the fraction, if you had a decimal, if you got 8.166666 repeating, you're also correct. Just make sure you stick a pi on the end of that. So our final answer here is 49 over 6 pi. So just a little bit of extra work in this one. If you're saying, well, we used the same formula, we did, but there was that extra bit of work we had to do first to figure out what our central angle was, since they didn't give that to us. All right, one final example here. This is another one that they give us the area of the sector. It says in the diagram below, the area of the shaded sector of LMO is 2 pi. So area of the shaded sector is 2 pi. If the length of NL is 6, what's the measure of angle N? So I'm going to make sure I know that my goal here is to look for that angle. Slightly different this time because we're talking about the area of the shaded sector, this yellow area. And when I use my formula, angle over 360 equals SA for sector area over total area. I actually don't have an angle at all, but the angle that I'm going to start to find first is this one here coming from the sector. So I'm going to go ahead and rewrite this as x over 360 because, again, I don't know what the angle is. It told me the sector area over here was only 2 pi, so that's going to go in for sector area. And what did it say? It said N to L was 6, so I didn't jot that down yet, but N to L is 6. Now notice N to L is going through the entire circle. It's passing through the center, which means 6 is going to be our diameter, and the radii then are each going to be 3. So a little trickiness here going on that you want to make sure you're using 3 for the radius, not 6. Off to the side, I'm going to go ahead and do my area formula so I can figure that out. A equals pi r squared. Again, my radius is 3. 3 squared gives us 9 pi. So the 9 pi gets to go in the total area spot. Again, this works out because a pi over a pi cancel out. When you cross multiply, 9 times x is 9x. 2 times 360 is going to give us 720. And I divide both sides by 9. X equals 80. All right. Now, little thing here, and please hope you caught this before you turn the video off. What we just found for x, if we go back, is we actually found the area of this sector. We were using our sector area formula, which means the sector has to come from the center. So our central angle, this piece here in blue, is what the 80 is. All right, I apologize that I did an x and then an x standing for two different things. So that 80 is the central angle, but since it's a central angle, it's also the measure of the arc. This arc is also 80. So the angle was 80 and the arc was 80. X, what I'm looking for though, x is an inscribed angle. So thinking back to the very first day, angles that are inscribed are half of their arcs. So if this arc in blue is 80, that means our final answer here, the angle N, MNL, is actually going to be half of that. So the measure of angle N is 80 divided by 2, again because it's an inscribed angle. So the measure of angle N is only going to be 40. All right, please, please, please double check that. This was a very tricky question in the exam. I forget if it was multiple choice or not. But if it was, a ton of kids picked 80 because you fall into that habit of the first thing you solve for, you always assume is your answer, which is not actually always the case. So please be sure to double, triple check that. So this was sector area. Again, making sure that you have this formula here memorized because it is not anything that the Regents will give you. They will give you that total area formula though of pi r squared. But you have to remember the setup. All right, so try some practice problems to make sure you have that in your head, and then we'll see you next time.